In the previous video, we have discussed how to convert finite automata into regular expression. In this video, let us discuss about how do we convert regular expression into finite automata. Basically, we are going to use Arden'S theorem. So basically, it means that if our equation is in the form of R is equals to Q plus RP, then the regular expression of that particular equation is R is equals to Q P star. Okay. Let us solve it through an example. So basically this is the given finite automata and we need the regular expression of final state, but we have two final states over here. So what we'll do is we'll calculate regular expressions for both these final states and then do the union of it, like we'll just add it. So here we write these equations according to the incoming states. For Q1, what are the incoming states? See, for Q1 on 1 goes to Q2. This is outgoing state. Incoming state means the arrow should point to that state. So Q1 0 is pointing to Q1, right? Are any states pointing to Q1? No, only Q1 dot 0. So Q1 is equals to Q1 dot 0 plus epsilon. We write this plus epsilon for the initial state. What is the initial state over here? Q1. This is also a final state and an initial state. How do we say that it is an initial state? Because it has an arrow. Okay. So Q1 dot 0 plus epsilon. Now Q2. Q2, what are the incoming states of Q2? This is one arrow and this is one arrow. Q1 dot 1. Q1 dot 1 and Q2 dot 1. Q2 dot 1. Now let us go to Q3. What are the incoming states of Q3? This and these both. So Q2 dot 0, Q3 dot 0, Q3 dot 1. Okay. Now let us first take Q1. Q1 is equals to Q1 dot 0 plus epsilon. See, this is in the form of R is equals to RP plus Q. So we'll just write R is equals to Q P star epsilon 0 star. Epsilon into 0 star is nothing but 0 star. Now Q2 is equals to Q1 dot 1, Q2 dot 1, right? We'll substitute this Q1 value over here. 0 star into 1 plus Q2 into 1. Now this is in the form of R, Q, this whole term is Q, and this is R again, dot P. Now we can write it as Q P star. So 0 star into 1 dot 1 star. So this is the new Q2 value. We don't have to calculate this Q3 because we actually need the regular expressions of Q1 and Q2. And in this, do we have any Q3 value to substitute? No, so we won't solve this. We can just get the answer through these two states. We got 0 star and 0 star into 1 star. So the regular expression is 0 star plus 0 star into 1, 0 star dot 1 dot 1 star. Okay. We did union of these two because there are two final states. We need the regular expression of the final state. That would be the answer of this. Let us look at a different example. First, we have to write the equations. For Q0, are there any incoming states? No, but it is an initial state, right? So we'll take epsilon. For Q1, we have two incoming states, Q0 dot 0, Q1 dot 0. We'll be writing that. For Q2, we have two, Q1 dot 1 and Q2 dot 1 incoming states. For Q3, we have four incoming states, Q0 dot 1, Q3 dot 0, Q3 dot 1 and Q2 dot 0, right? We'll be writing them. What is the final state over here? Final state here is Q3. So we can just solve the regular expression of Q3. But in Q3, we have to use Q0, Q2. So we'll be solving and Q3 also. Yeah, anyways. So we need to solve Q0 and Q2, right? But in Q2 we used Q1. So we have to solve Q1 also. Basically we have to solve all these expressions to get the regular expression of Q3. Okay. So Q1 is equals to Q0 is epsilon. So we don't have to solve it further. For Q1 we got Q0 dot 0 and Q1 dot 1. This is already in the form of R is equals to Q plus RP because Q0 is nothing but epsilon. So we'll be doing Q P star, which is nothing but epsilon dot 0 which is nothing but epsilon dot 0 0 star, because q p star, epsilon into anything is that value only, right? So q1 is nothing but 0 0 star. Now look at the q2 value. q2 is nothing but q1 dot 1 plus q2 dot 1. Substitute this q1 value in this. So q2 is equal to 0 0 star dot 1 plus q2 dot 1. This is in the form of r is equals to q plus rp. That is what we needed. So q p star, that is nothing but 0 0 star dot 1 into 1 star. Now we'll be solving this q3. Substitute q0 value and q2 value. q3 just take it common, like q3 into 0 plus 1. We already discussed, right, in the regular expressions, if it has a plus b, then it means it goes to the same final state, same state using different paths. Here it will be a, here it will be b. So that is how we do it. So q3 into 0 plus q3 dot 1 is nothing but q3 of 0 plus 1. So this is q, this is r, and this is p. So we'll do q p star, which is nothing but, we'll write it as it is, we'll ignore this epsilon, and 0 plus 1 star. So this is going to be our answer, because we have to solve the regular expression of the final state when they ask us to convert the finite automata into regular expression. Thank you.